Okay, well, thank you everyone for coming today. If there are anyone who don't know who I am, I'll just introduce myself. So my name is Stine Johansen, and I'm a postdoc in the Australian Cobotics Centre in the Human-Robot Interaction program. And what I will be talking about today is a research study that we've just completed. So we've done this over the past few months. A research study focusing on how we illustrate robot movements. It's a survey of human-robot interaction illustrations from proceedings from the Human-Robot Interaction Conference from 2016 to 2022. So I'm looking forward to sharing that with you and perhaps having some interesting discussions after this. So this is a photo that is used a lot in the center. It shows two people collaborating with a robotic arm, and in that collaboration, the robot arm obviously moves in different ways suitable to the task that the people are trying to achieve in this sort of manufacturing setting. And in the center, we have all kinds of different partners, and for all of them, we are aiming to design cobotic systems that can complete these specific tasks. But obviously that will, obviously the movements of the robot will depend on the specific task that that the robot and the people are aiming to complete. So in that sense, the movements can vary a lot, and that's why it's important to also work out ways so we can support designing those movements. So that's sort of a background setting to what we have been working on. So we've asked this question: what are the current ways that robot movements are illustrated in human-robot interaction literature? So currently there are many ways that we can supply supplemental materials to show the robot movements that are in a study, or that are designed. So we can include videos to our paper, so we can include videos when we do presentations, but the static 2D illustrations are still the primary way that we communicate these movements in our research. So that means that they're actually very essential to our communication, but also the way that we communicate visually, the things that we design are actually often a fundamental thing in how we develop new knowledge. So we are interested to see how we are communicating these robot movements in the HRI community, and how that could play a role in how we design the movements. So the study that I'll present today, we've identified a body of illustrations that show robotic movement, and we've annotated these illustrations and then identified new opportunities for human-robot interaction design. So just to say that there are two main contributions to this work. So the first is a set of considerations to think about when illustrating robot movements, and this goes to both research dissemination, but also to other communities and internally in design teams, for example. And that leads to the second contribution that we have, which is how these illustrations can then play a role in the design of robot movements. So as a background to all of this, there are lots of information hidden in expression, hidden in different kinds of movements. So that's something that we learn early on as children, even the ways that we show intent and expressions with our movements, such as waving or pointing and so on. So previous research, other research areas have already been looking into how we can document that information that's in those movements. And particularly this has been the case for research in dance. So this illustration in the middle of the slide is a dancing alphabet that seeks to, describe different types of movements and what information is integrated into that movement. But documenting dance moves has existed for several centuries. So the illustration to the right in this slide is a very old illustration from the 15th, 16th century that shows how a dance progresses throughout time. And one thing is to, document this dance, but as I said earlier, these diagramming methods have actually also played a role in how the dance itself has developed. So we're thinking that, that might also be the case when we're designing robot movements. So actually, Laban notation is one system for describing these body movements and analyzing them. It's widely used in dance choreography, and it has already been suggested by other researchers that could be useful as a notation for designing movement-based interactions, but also in robotics research, it could be useful for as a structure for recognizing and modeling human movement to then transfer those movements and thereby also the emotional expressions hidden in those movements to robots. So from a human-computer interaction perspective, visually representing movement has also already played a role. So especially in the areas of gestural and tangible interaction, where it's been important for the research to progress, that we could actually document those movements and that we could share them with other researchers as well. So we've looked into particularly those fields of tangible, embodied, and gestural interaction, where these vocabularies have been described that link sets of gestures to certain interaction commands, and they often depict them in these sets of photos that are overlaid with graphical arrows and so on. So that's a typical way in that area of human-computer interaction where we document and describe these movements. But as we've looked into this in that area, in this wide area, it's still very common to just see these static representations. And often they only include, for example, one photo. So the picture that I show on the left here is actually unusual in that it does describe how movement progresses. That's not the case, often the case in HCI research. So there aren't any ready answers to how we could go about showing robot movements in more diverse ways. But of course, there are already methods and tools that are very useful for describing how a robot could move. So one area of this is published by this book by Peter Kork, which I'm guessing that most of you are probably familiar with. And that describes the use of coordinate frames as a tool for describing movement. So in the illustration to the left side here, it's two coordinate frames, the blue and the red one, relating to a world point, the point P, and it describes how one of the frames is transformed with relation to the blue frame. So that's one way to describe a movement in a very abstract but very useful mathematical way. And of course, movement visualizations have also been thought of in other areas of robotics research. So specifically looking into how visualizations can be used in interfaces to show, for example, robot intention. So researchers have already utilized technologies such as projections, as you can see in the top photos here, projecting the trajectory of a robot, or augmented reality, as you can see in the bottom picture here, where these researchers looked into different ways that we could visualize a a robotic trajectory, a robotic path using augmented reality. So there are already ways that visualization plays a role in human-robot interaction research. But this is, of course, related to the final interface, the final design of the robot, and not so much how researchers or design teams use visualizations. So that still leaves open the question that we had in the beginning. So therefore, we've conducted the survey study, and what we did was we looked at the proceedings from the International Conference of Human-Robot Interaction. We started from 2022, and then we just went backwards in time until we reached a certain point of saturation in our results. So that means that we've looked at about 1,200 papers and identified about 180 illustrations that all show a robot movement in some way. So what we did then was we categorized these illustrations into different visual styles that I'll show you in a minute. We identified 10 visual styles, and then we organized all of these illustrations according to these styles and annotated them to identify certain characteristics that each style has, and if there are any themes that sort of went across the illustrations. And then we conducted a final review of all the illustrations to, corroborate the codes and annotations that we made. So this is a very chaotic overview of all these 10 styles, and I'll go into all of them. But I just wanted to mention that, we can already see that there's a huge diversity in ways that we can show robot movement. And this is just our reproduction of those styles. There could be many ways to utilize each visual style, and I'll show you that in a minute. But first, maybe just to say that this is how these styles are actually distributed. So even though there are many ways that we can illustrate robot movement, the main ways that we found was using some kind of arrow or using some image sequence which shows different poses throughout time. So those were the main ways. As you can see, for example, using motion blur, we only found one illustration to utilize that visual style to show movement. So then we took as we had identified these 10 styles, we took all of the illustrations and we organized them into this virtual whiteboard. I won't expect you to be able to see these individual illustrations. So this is just to give you an overview of what we actually did. So we had this virtual whiteboard with all of the illustrations that we'd organized into the 10 different styles. And then we used that to do our annotations to do the next part of the analysis. So in order to do that, we developed a set of codes that we used to annotate the illustrations. So these codes related to any kind of interaction, if the movement was related to an interaction between a robot and a human, how it showed the specifics of the motion or the movement, if it contained any information about the study context or the context of the design, and what kind of quality the illustration contained. And then we also looked at what kinds of movement that the illustrations portrayed. So as you can see, most of them show some kind of robotic gesture. So that means that it's a set of movements to make some kind of expression, either emotional or other kind of gesture that shows some information. And the next one is locomotion, so just showing that the robot changes its position somehow. But I'll go into these illustration styles now. So the first one that's mostly used is arrows. And as you can see, an arrow is not just an arrow. There are so many different ways that people use this to show robotic movement. So one way could be to have a room schematic, and then you draw an arrow to show a general direction of a path. or trajectory that the robot moves in. It could also be, as you see in the top middle picture, to show some indication of how an interaction will unfold. And in the bottom middle, they've actually removed any information about the robot and the context, and just purely focusing on the movement itself, as sort of almost a taxonomy of movements. And then in the right side, they wrapped the arrows around sketches of the robot to show how individual joints might move. So then we identified a style called lines. And you might think that, well, lines, that looks pretty similar to arrows, but actually what we found was that there are a lot of differences in how authors use arrows and lines. So lines are often used to show a precise trajectory of a robot. So for example, in the top left picture, the illustration shows the actual path that a robot has taken in an environment. The same goes for the bottom left, which shows paths of a drone robot. So that's actually based on data from the actual study that they did. The right-hand side illustration, on the other hand, shows a simulation where they calculate potential trajectories of the robot, but still that shows, an exact path, and not just a generalized direction of the movement. So on the in a completely different style is image sequences, where authors are showing exact poses throughout time using photos most often. So this gives a very low level abstraction way of showing how the robot will move. And as you can see, it varies a lot how many pictures people are using. So some of them you get almost a feeling of how the movement progresses, whereas others tend to show an end position and a start position and an end position. Then similar to that, some authors use image overlays. So in that, using that style, you're not just showing the progression, but you're also showing the progression in relation to previous poses. And we also found this bottom left picture, which actually shows a whole storyboard of how an interaction unfolds. So we only found, I think, five examples of authors that show some kind of storyboard, which was kind of surprising. One thing that is sort of a limitation to using this kind of style, though, is, as you can see on the right picture, is that it can actually be almost difficult to see the individual poses of the robot. So they've overlaid so many pictures to almost give a sense of the trajectory of the robot, but it also leads to it being difficult to actually see how the movement progresses. So another way to do something similar is to use, we call it dots, but as you can see in the middle picture, it could also be, using pictures of objects throughout time. So what's really interesting about this visual style is that you can use that to show particular poses or points in time. So if you look at the left side illustration, you can see how the movement actually progresses, whereas the top, the one with the orange dots, it progresses, the speed of the motion is constant throughout the movement, whereas the bottom one, it speeds up at the beginning and at the end. So there's sort of like a Bézier curve to the movement. Then there's an image cluster style, which shows scattered, organized movements. So this could be in photos or in sketches, as you can see, sometimes they're organized, as you can see in the top right illustration, where they've sort of organized the movements into how open or closed this robotic mouth is. And then there's the coordinate frames, which of course is fundamental in the field of robotics, but there are many different ways that researchers are using coordinate frames to show movement or show the space of a movement. So one way is to attach a coordinate frame somewhere in the space around the robot, as the one in the left-hand side and the top middle picture, where they've just attached a coordinate frame to show the general space of the movement. But in other cases, as in the bottom middle picture here, they've attached these coordinate frames to the individual joints, which gives a more precise description of how each individual joint of the robot might move. Then, in a completely different style, some authors use this cartoonish way to give an indication of a movement. So this can be really helpful in terms of giving a very low-tech way of showing an indication of a movement. And maybe you've already noticed this, but not a lot of these illustrations across the styles have actually included people. So this picture on the left-hand side shows how the robot moves intimately in relation to a person. And one thing that we found in the study, which I think was really interesting, was that it really varies a lot how people are represented in these illustrations. So you can also see an example of that in the right-hand side, where a person walks up to a robot. And in both of these illustrations, the left-hand and the right-hand side, the people and the robot are represented in very similar graphical ways. But we actually found a lot of illustrations where the robot is shown with a picture or a photo, or in a very detailed graphical drawing, and the person, on the other hand, is just shown as a stick man, or shown in a very simple way. So that really puts the emphasis on the robot side of the illustration. So that was really interesting and unexpected when we started the survey. We then came across two illustrations that show the movement using graphs instead of coordinate frames. So as you can see on the left-hand side, this graph shows the angle of a head movement from this Pepper robot as it progresses over time. And then finally, as I said, we found one illustration that showed motion blur. So in this illustration, they're trying to show that one of the study participants knocked over the robot. So they're trying to show a sort of aggressive movement, and they're using motion blur to kind of emphasize the physical nature of that interaction between the person and the robot. So based on all of that, we've described a set of considerations that can be useful to make whenever you're thinking about doing illustrations of robotic movements. So the first one is about the accuracy of the movement. So we found that it varies a lot how accurately the robot motion is described. So some might show a general direction of the movement, whereas others provide an exact trajectory of the robot. So you want to consider the importance of that accuracy and consider how much information is actually necessary for you to communicate. The second consideration to make is whether you want to show a continuous movement or instances of movement. So in some illustrations, it might be very important to capture specific poses throughout the time of throughout the period of the movement, but in other cases, it might be more important to show how the movement progresses in a more abstract way. Then the third consideration relates to how people are depicted. So as I said, a lot of the illustrations that we found actually put a lot of emphasis on the robot and not so much the person. So an important consideration to make is to think about how the person interacting with a robot is depicted. So not every paper should, of course, include movement that's related to people in some way. That's only if that's actually the case for the study or the design. But if it's the case, we definitely see an opportunity for us to consider more systematically how we could depict people in relation to robotic movement. And then finally, an important consideration to make is whether the illustration emphasizes if the movement is a simulation, or if it's recreated, if it's only still a conceptualization of a movement, or if it's actually been captured from an experiment. So the next part of this relates to how we might use some of these things in our design processes. And I just wanted to take a step back and share these pictures from my own PhD research. So this was from a prototype development that I did a couple of years ago. I was developing this prototype which had a lot of mechanical movements, and it might have been very attractive to just go ahead and start building the prototype mechanically to explore different ways that it could move. But it was extremely essential to me to make sketches and draw out these movements before I went ahead and built the prototype. So sketching is already a very common way that we explore movement in interaction design and human-computer interaction, and I'm guessing in other related areas as well. So there are ways that we could learn from that and apply that to design of movement in human-robot interaction. So taking all of this into a design process, we have described or identified 4 different ways that could be valuable. So the first is obviously describing the movement. So with that, we want to emphasize that there are all of these diverse styles that we want to that we hope could be useful in communicating between researchers and between designers, but also understanding those visual conventions that come with each of these styles. So for example, coordinate frames are very unambiguous. They show a movement in a very precise way. It could be very, very helpful in terms of testing solutions and specifying details that need to be implemented by engineers, for example, whereas other types of visual representations might have a lot more ambiguity, such as, for example, arrows or just doing cartoonish motion squiggles that might be more helpful if you're earlier in the design process. So the next one is enriching field studies. And even though several of the illustrations that we found show some kind of context where a human-robot interaction, for example, takes place, the focus is often not on the context itself, but it's rather on the interaction between the person and the robot. So we think that there are actually opportunities to include other styles that might emphasize that context and help thereby frame the movement in a different way. So that could lead to potentially other research challenges that we're not seeing right now. And another part of this is, of course, also how we represent the end users in our illustrations. So that leads to the third point, which is supporting user involvement. So if you're using coordinate frames, that might be a high barrier for people from a non-technical background to understand the movement that you're designing. So if you want to engage with end users from non-technical backgrounds, it could be really helpful to think about how different illustration styles support discussions between different kinds of people, people from different kinds of backgrounds. And that also emphasizes the importance of diversity and inclusion in our visual representation. And finally, documenting the design process is a noticeable lack that we found in the illustrations that we got in our survey. So even though there are lots of illustrations, very few of them actually show how a movement was designed, or show how the design of the movement progressed throughout the design process. So we could think about, how we can be more transparent about the design decisions that we make along the way, and that will be helpful in terms of building on that research. But of course, this work isn't done yet. So for future work, we see lots of different directions that this could go in, but one aspect would be to look at how diversity and inclusion is encapsulated in these kinds of illustrations. And it could also be very interesting to look at differences between anthropomorphic, zoomorphic, and non-anthropomorphic illustrations of robots could look like. So for anthropomorphic or zoomorphic robots, as humans, we already have an expectations to how these robots will move. For non-anthropomorphic robots, that might not be the case, and we might not have an immediate idea about how that robot will move. So that it might be interesting to look at how we could visually represent those in different ways, or if we're maybe missing something right now. And then obviously we focus on the Human Robot Interaction Conference, so there might be other publication outlets that could be interesting to also look at to get a more diverse perspective on how researchers are representing robot movements. But that's my presentation for now. So thank you for listening, and I want to leave you with one question to think about, how you use illustrations in your work. And I'm happy to answer any questions at this point. Thank you.
Wow, thank you so much, Stine. That was
if anyone has any questions, please put them in the chat or just speak up.
That was really amazing, Stine.
Oh, maybe. Oh, sorry. I think I have sound now.
Can you hear now?
Yeah. Thank you.
Congratulations, Stine. That was really, really amazing work. So interesting to have identified, that range of way of communicating, all the different styles and the observations that you've made. So I'm sure there's a number of questions in the audience. So let's see if anybody has a question. We'll give people a minute. I guess I have a question, and for you, Stine, what was the most, I guess, surprising aspect of your findings? Like, what was something that you really weren't expecting to identify or encounter in the study?
Well, definitely what I was saying about how people are represented in these illustrations. So we actually found a lot of illustrations that use the same picture for showing a robot and a human, of using very, very subtle differences that made it almost impossible to distinguish between the person and the robot. So that was really surprising, I think, and yeah, an important thing to consider going forward.
Absolutely. Yeah, it'll be interesting to see how this continues to inform the next stages of your work. I guess for you, what would be the next step? I mean, you did mention those other areas that you want to look at, diversity and the zoomorphic aspects and stuff, but how do you see that coming into what you're planning on doing next?
Yeah, for our side, the next step is to look at how this might be integrated more systematically in the design process, how it actually could play a role in the design process. And Markus and Jared, please jump in if you know you have anything else to say. But we're really interested to see how different illustration styles might play a role in that design of robot movement. So that will be our next step in this research.
Excellent.
It's also just to add, it's quite aligned to two of our projects. So robotic intention visualization is an obvious example, and then the prototyping toolkit as well. So I think this is great groundwork for us to consider when moving forward with some of these projects.
Yeah. So for the sub-project on prototyping toolkits, that's about engaging with end users to prototype new designs of robots. So I think this will be helpful in terms of developing approaches to that.
Yeah, absolutely. Anyone from our audience have any questions for Stine or Markus or Jared? How about Markus and Jared, in terms of you've mentioned what you think is going to be the next steps, but do you have ideas as to other ways to, I guess, other venues where you might be able to publish this work or share these outcomes?
That's a good question, Glenda. One of the things we recommend, so did you mention, Stine, that this is actually a submission that we've made to a conference?
I think I didn't mention that.
So yeah, we have submitted this work to the HRI conference that's currently under review. That was why we focused on that conference as well. But one of the recommendations we made in that paper was, if you look at other publication venues, they've actually brought in kind of categories for submissions called pictorials. So both the Designing Interactive Systems Conference and the Tangible, Embodied and Embedded Interaction Conference have these pictorial submissions. And we think that might be something that the human-robot interaction field could look at. And as for next steps for us, we think that it would be really interesting to investigate further this idea. How do we actually use drawings in our design process? And reflect on that and prepare a pictorial presentation probably for the DIS conference.
Cool.
That's where we would be looking at next. Yeah.
Sean has a question.
Thanks, Stine. That was terrific. Did you look at did different journals have different styles of presentation, and did you see any, with a particular speciality or a particular discipline that they illustrate it in a certain way? Are there different tribes, if I can put it that way, across different journals and publication outlets?
So this survey was just conducted on proceedings from the Human-Robot Interaction Conference, but I would imagine that there are definitely tribes. So if you looked at how the styles were distributed, in the human-robot interaction community, they might use a lot of simple arrows to show robot movement. But I'd imagine that Peter Kork's work and others in using coordinate frames would be highly influential in other robotics communities.
I suppose maybe a follow-up question would be, or a comment is, I'm wondering if it actually tells us about, particular disciplinary expertise as to the way they see the problem, and how that results in terms of the illustration and whether that's actually useful or not.
Yeah, I think it could be. And Jared, do you have a?
Yeah, I mean, I think particularly if you think of social robotics, which is sort of a part of human-robot interaction, there's a lot more emphasis on illustrating the emotional kind of movements, facial gestures, expressive hand gestures, rather than sort of movements through space that we would see in the kind of illustration of drone unmanned, drone movements. So there's different differences in those sort of sub-tribes of human-robot interaction.
Yeah, the types of robots would obviously play a huge role in how it's
I'm sorry to cut you off. I didn't mean to. I just, is there going to be do we want a universal language? Is that what we're aiming for here?
One of our main points is actually to recognize the diversity of different ways of illustrating movement, and just to be able to make informed decisions about what's the best way for a particular case. We're definitely not naive enough to be sort of suggesting a universal language for movement.
And we don't want to be prescriptive in any way. This was actually to say, it does matter how you illustrate. So you might want to consider these aspects when you're illustrating. It wasn't to say this is the way that you should illustrate something. Yeah. Oh,
Great,
did we have a question in the chat? So L writes, in your survey of existing illustrative research, which field or industry was the most prevalent in attempting to illustrate? So when you say which field or industry was the most prevalent, so, we only looked at the human-robot interaction conference, but are you thinking about the context of the movement, like if it was mainly industrial, or if it was, that was actually something that we didn't look for in our survey, so that would be super interesting to look at. I think
we should mention that we've made the corpus available.
Oh yeah, so we in the paper submission, we've also made the whole corpus of collected illustrations available. So as soon as hopefully it's accepted, we can share all of that. But I'll also be happy to share that internally in the ACC.
Fantastic. Wow. Thank you so much. That was really, really so interesting, and good luck with the submission. Fingers crossed. And we really hope you get to share that in a more global audience as well, because I think it will really be impactful research. Excellent. Well, thanks everyone. We're at 11 o'clock today, so we will let everyone go on with the rest of their day, and we'll see you all soon. And thanks to the team. Thanks Program 2. Excellent work. And we'll see you all soon. Bye.